Alright guys, today we are talking about states of matter. Alright, we're talking about states of matter, so you should be following along in your notes. Here we go. The state of matter is the form in which matter is naturally found, which is based on two different things. It's going to be based on, here we go, temperature and pressure, okay? So states of matter are going to be based on temperature and pressure, and as you change one or the other or both, your state of matter can change. We're going to talk about the different states of matter, and today I have with me my beautiful wife who's going to help me out. So here we go. We're first going to start with solids. So here we go. We got a solid right here. This is a tennis ball. It's solid. It keeps... I just needed one. Thanks, babe. Hard to find good help these days. So, solids. Alright? And, this is ridiculous. Alright. Solids have definite shape and definite volume. Alright? They have definite shape and they have definite volume. If we look at a solid here, alright, you can see this is the structure of a solid. So we got all of these atoms held together here. They will be vibrating slightly, okay? So believe it or not, solids do move, and these atoms vibrate back and forth. Alright? They have high intermolecular attractions. Ooh, big word. High. I won't even spell that one out. So they have high, still getting used to this pen, intermolecular attractions. Alright, meaning, or forces, meaning these particles here are going to be held together. These particles here are going to be held together tightly. They like each other, okay? So they have strong forces holding them together, which is why solids are hard when you hit them. Okay? And, as you see that, oh, it's written on the bottom there. I just now saw that. Alright, so they're tightly packed together. Alright? They're solids. Next thing we have is liquids. Thanks. Thank you. Thank you. We have liquids. Yes, we do. This is kind of absurd. My wife just threw water all over me. So next thing we have up is liquids. She even got on the screen. So here we go. They take the shape of their container. So liquids take the shape of their container. They flow, okay? So liquids will flow. Okay? So they like to flow, moving over each other. Alright? There's less intermolecular attraction between these. So these particles, alright, they will hold together. So they hold together a little bit. But as you can see, they're a little spread out. They're not as organized here. Okay? So they will slide past each other very easily. Okay? So those are liquids, and I've got liquids all over me now. This is ridiculous, okay? So, next thing we have up, we have gases that are up. Alright? Thanks, babe. Yes, that's gas. Alright? Ever seen one of these? This is an air zuka. It actually shoots a ball of air out. So there's your gases. So as you see, it knocked the paper towel out of my hand. So we have gases. Gases, no definite shape or volume, expand to fill their container. And weak intermolecular forces, as we can see here, okay, these gases are all spread out, and these two particles don't really attract very much. They attract some, right, but not a lot. So they have these weak intermolecular forces that are trying to hold them together, which is why gases are all spread out, and when I karate chop across the air, it doesn't hurt. If I karate chop a solid, it hurts a little bit. Alright, so we're going to look at all three of them here. You can see here, if you look right here, we have our solid. You can see those are vibrating, okay? So you have your solid. I don't know why this thermometer is lower. It should be higher, so we'll pretend that's red up to here. All right? So we have our liquid that's being heated up. You can see these are spread out a little more. Okay, these will be able to flow over each other. And lastly, we have our gases that are moving like crazy. All right? So gases are all spread out. All right? So solid, liquids, and gases. Basically, especially for right now, we're going to think of it as if I want to change a solid to a liquid to a gas. You heat it up. If you want to go the opposite way, cool it down. Alright, one more state of matter we're going to look at is plasma. Alright, plasma, not really found on Earth except, at least naturally, except in lightning bolts. Okay, so in lightning bolts there's plasma. Alright, it's also found naturally in the sun. And what plasma is a Let's get our pointer back here. Okay, plasma is gaseous form of atoms floating around. So think of a gas, but they've actually had their electrons ripped out from them. So that's what really plasma is. You can actually form plasma in a microwave too, but I'm not going to tell you how to do that because I don't want you trying it at home. Maybe we'll talk about it in class. Okay, it's also naturally found in the sun and stars. So these outer electrons are ripped off of a gaseous atom. That's what plasma is. Okay, so what is a state change? Okay, that's the next little bit we're going to look over here. So what is a state change? Okay, a state change means that a substance has changed from one state of matter to another. Okay, an example, water freezing involves a state change from a liquid state of matter to a solid state. And we can show this as this. So this right here, this might be the first time we've done this. We actually have a chemical equation down here. Okay, we have an equation down here. That's an L right there, that stands for liquid, and that's an S right there, that stands for solid. And so here's water changing from a liquid to a solid. All right, that's interesting happening things to that snowman there. Are these pictures of chemical or physical reactions? Okay, are these pictures of physical or chemical reactions? What do you think? Say it out loud. Yell it. Hopefully you said physical. Okay, physical. As you see, the snowman's melting down here and all that kind of stuff, but it's still H2O, water, so it's just physical. Alright, so are state changes physical or chemical changes? And why? We're going to talk about this in class. I expect you to have an answer written down. So go ahead and write down an answer to this. Both of them are state changes, physical and chemical changes. And tell me why. I expect you to defend your answer. So I want some good writing here. Alright, so have your answer ready tomorrow when you come into class. Alright, let's talk about state changes. We'll go through them fairly quickly. Alright, fusion, or also called melting. Both of those are interchangeable terms. Solid to a liquid. Oops. So there we go, solid to a liquid. You can see this when ice melts, or our lovely snowman melting there. Solidification or freezing. This is when we go from a liquid to a solid. Alright, liquid to a solid. So this is freezing. So when you put your water in the freezer and make those little ice cubes, they will freeze, and there's your freezing. Alright, next one we look at is vaporization. Alright, every once in a while they'll call this evaporation, or you can also add on here, and it's not, so I'm going to write it up there for you. Vaporization, also boiling, that's boiling, is also a form of vaporization. Okay? And you can see our liquids turning to a gas down here. I don't know what that purple substance is in that animation, but it's bubbling from all kinds of places. So liquid to a gas is vaporization. Alright, we have condensation. This is when gas goes to liquid. So condensation, when gas forms to a liquid. This is like when, especially in the summertime, you have a cold drink outside, and all of a sudden water starts getting on the outside of your drink. That's actually water particles in the air condensing, going from a gas to a liquid on your cup. Alright, sublimation, solid to a gas with no liquid in between. Oh, this is some of my favorite stuff. We will see some of this year. This is dry ice. Okay, so over here, right up here, that is dry ice. It goes from solid to a gas. And then we have the exact opposite of this. This one you might not have heard of, so deposition. Gas to a solid without becoming a liquid. CO2 can reverse. So if you take gaseous CO2 and make it really, really cold, it'll become a solid. You'll make dry ice again. Alright, and just an overview, we see here we got gases up top here, all spread out. Your liquids come back together a little more, and your solids are definitely together. If you go up this way, you go from melting to vaporization, or you can go straight up to sublimation to a gas, and back the other way. And lastly, another little thing to look at here. Oops. Alright, we got all our different ways. We can go from a gas to a liquid to a solid to a gas, right? So we can do all these different things, and here are your names. So if this little chart, there's a chart here, okay? You might want to draw that in your notes.